Imagine this. You're sailing on a calm, endless ocean. The sun is shining, the wind is gentle, and everything seems perfectly normal. Then, without warning, the water in front of you rises higher and higher until a towering wall of water over 100 feet tall crashes toward your ship. There's no storm warning, no tremor in the waves, just an impossible, sudden giant. For centuries, sailors reported encounters like these waves so massive and sudden that they seemed to appear out of nowhere, swallowing ships whole, leaving nothing behind but floating debris and terrified survivors. Yet for a long time, the scientific community treated these stories with skepticism. How could a wave that defied the laws of physics possibly exist? Tales of these monstrous waves were dismissed as sailor exaggerations, folklore, or just bad luck. But the truth is far stranger than fiction. These rogue waves, as they are now called, are very real. They strike without warning, and even the largest, most advanced ships cannot always escape their fury. Today, we're going to dive into the science, the history, and the terrifying reality of the ocean's most dangerous giants and uncover why for so long the world thought they were impossible. For centuries, the ocean has inspired both awe and fear, a vast, unpredictable force that can shift from calm to violent in an instant. Mariners throughout history have told stories of colossal waves appearing without warning, waves so enormous that they seem to defy logic and physics. These tales, often dismissed as sailor exaggerations or maritime legend, describe events where entire ships were swallowed by walls of water, leaving no trace behind. Yet modern science has confirmed that these monstrous waves are not just stories, they are real phenomena known as rogue waves. In recent years, the internet has amplified the mystery of these waves with sensational titles claiming that scientists refuse to admit their existence. Viral videos dramatize rogue waves as conspiracies or hidden truths, feeding the idea that the scientific community turned a blind eye. In reality, science requires evidence, measurements, and repeatable observations before accepting any phenomenon. The early skepticism surrounding rogue waves was not denial, but caution, based on the limitations of historical wave modeling and sparse oceanic data. Today, we can explore the truth behind these so-called monster waves with a combination of historical accounts, eyewitness testimonies, and modern scientific observation. Through the lens of research and verified measurements, we will uncover how rogue waves form, why they were once considered impossible, and the real danger they pose to ships, platforms, and lives at sea. What once seemed mythical is now part of our understanding of the ocean's most extreme phenomena. Today, we'll uncover the truth behind these monster waves and why the ocean is far stranger than we ever imagined. What are rogue waves? Rogue waves are some of the ocean's most mysterious and terrifying phenomena. Unlike ordinary waves, which rise and fall in predictable patterns, rogue waves can suddenly tower more than twice the height of surrounding waves. Imagine a sea that appears calm, then within moments, a single wave rises seemingly from nowhere, dwarfing the rest and crashing down with overwhelming force. These waves are not caused by earthquakes or tsunamis, which originate from seismic activity or underwater landslides. Instead, rogue waves are extreme surface gravity waves formed by the complex interactions of ordinary ocean waves that concentrate energy into one massive, unexpected peak. The unpredictable nature of rogue waves is part of what makes them so dangerous. Mariners have reported encountering these monsters without any storm warning or unusual weather signs, often leaving crews with mere seconds to react. The wave's sudden appearance is the result of either linear superposition, where multiple wave systems align and combine to produce a taller crest, or non-linear focusing, where energy from surrounding waves transfers into a single wave, amplifying it far beyond the average height of the sea state. Could one of these waves reach 100 feet while you're on a small boat? The answer is yes, and there are documented cases where waves of that magnitude have struck unexpectedly. It is important to understand that rogue waves are fundamentally different from tsunamis. Tsunamis involve long wavelength, low-height waves that travel across oceans due to seismic activity, often imperceptible until they approach shallow coastal waters. Rogue waves, in contrast, occur on the ocean's surface, in ordinary storms or even relatively calm seas, and they rise suddenly, striking vessels or platforms directly. Their energy is concentrated into a single massive crest, which explains the sudden destruction they can cause. Modern instruments, including buoys and satellite radar, have confirmed their occurrence and allowed scientists to begin analyzing their formation in real time. Despite advances in oceanography, predicting rogue waves remains incredibly challenging. They are rare, but when conditions align wave trains converging, strong currents interacting with winds, the ocean can produce these extraordinary peaks. Understanding rogue waves is not just a matter of curiosity. It is a critical component in designing ships, oil platforms, and safety protocols for life at sea. The ocean's power is immense, and these waves remind us that even a calm horizon can hide extraordinary danger just beyond sight. Historical accounts. For centuries, sailors and explorers told stories of colossal waves rising from calm seas, waves so immense that they could engulf entire ships in an instant. In the 19th century, French explorer Jules Dumont d'Urville reported encountering waves that towered over 100 feet while navigating the Southern Ocean. These accounts were often recorded in meticulous logs and journals, passed down through maritime tradition, yet they were treated with skepticism by scientists. At the time, the prevailing linear wave theory suggested that such gigantic waves were physically impossible, a notion that conflicted with the first-hand experiences of those at sea. Stories of rogue waves were not confined to explorers alone. In 1910, survivors of the RMS Lusitania recounted being struck by enormous waves that battered the ship in what appeared to be otherwise calm conditions. In the harsh Antarctic seas, Shackleton's expeditions reported waves capable of breaking wooden masts and flooding decks, yet these were often dismissed as exaggerations born of fear and isolation. Mariners' testimonies seemed dramatic, even fantastical, but they consistently described waves far larger than those predicted by contemporary scientific models. Early oceanographers and physicists were cautious, not dismissive. The lack of reliable instruments in the open ocean meant that there was no way to measure or verify these towering waves. Observations were limited to anecdotal reports and post-incident damage assessments, which, while compelling, did not meet the strict standards of scientific proof. Scientists were not refusing to admit rogue waves existed, they simply could not confirm them quantitatively, and their models suggested such events were extraordinarily rare, if not impossible. Despite the skepticism, these stories persisted, haunting mariners and inspiring cautionary tales about the unpredictable power of the sea. Captains learned to respect the potential for sudden, violent waves, and logs from multiple voyages often mention walls of water appearing without warning. Yet, it was not until the latter half of the 20th century that instruments would catch a rogue wave in action, transforming centuries of sailor tales from legend into scientifically verified reality. For decades, these stories were treated as myths, until one wave changed everything. First scientific proof, Dropner wave. On January 1, 1995, in the cold, choppy waters of the North Sea, something extraordinary happened. The Dropner oil platform, a massive structure used for extracting oil off the coast of Norway, recorded a wave that would change oceanography forever. Using a precision laser sensor installed on the platform, engineers measured a sudden spike in water height, a wave towering 25.6 meters, or approximately 84 feet. Unlike earlier sailor accounts, which were anecdotal, This measurement provided the first scientifically verified evidence that such enormous waves were not only possible, but real. The Draupner wave confirmed long-standing tales from centuries of mariners. Stories that had once been dismissed as exaggeration or folklore suddenly had hard, indisputable data behind them. The wave appeared out of nowhere in what seemed to be moderate sea conditions, just as sailors had always described. Its height was more than twice the significant wave height for the area at the time, perfectly matching the modern definition of a rogue wave. This single, carefully recorded event provided a breakthrough for scientists who had long suspected that extreme waves could form under the right oceanic conditions. Prior to Draupner, rogue waves had been largely theoretical. Models based on linear wave theory suggested that waves of such magnitude were extraordinarily improbable. The Draupner measurement challenged these assumptions, forcing the scientific community to rethink the very dynamics of ocean waves. Researchers began to explore the mechanisms that could concentrate wave energy so dramatically, from linear superposition to nonlinear focusing, as well as the influence of wind, currents, and wave interactions. The event opened the door to a new era of oceanographic study, where previously dismissed phenomena were now scrutinized and analyzed with precision instruments. The impact of the Draupner wave extended beyond science. It validated centuries of sailor experiences and demonstrated that the ocean could produce unpredictable and deadly forces even under seemingly normal conditions. Offshore platforms, shipping routes, and safety protocols were re-evaluated to account for the possibility of rogue waves, highlighting the tangible danger these events pose to human life and infrastructure. For decades, mariners' stories had been relegated to the realm of legend, but the Draupner wave proved they were grounded in reality. This single measurement forced scientists to rethink the entire ocean. Since Draupner, dozens of rogue waves have been recorded around the world using buoys, radar, and satellite technology. Each new measurement reinforces the fact that the ocean is capable of sudden, extreme events that defy earlier predictions. The Draupner wave remains a landmark in oceanography, a moment when myth became science, and when the world realized that the sea still holds mysteries powerful enough to challenge our understanding. Modern observations and technology. Today, rogue waves are no longer just the stuff of legend. They are observed and studied with advanced technology that allows scientists to measure these extraordinary events in real time. Buoys drifting across the oceans continuously record wave heights, while radar systems installed on ships and offshore platforms provide precise surface measurements. Satellites equipped with synthetic aperture radar can detect unusually high waves over vast stretches of ocean, giving researchers a global perspective on these rare phenomena. These tools have confirmed that rogue waves occur more often than early models predicted, though they remain unpredictable and localized. Confirmed rogue waves have been recorded in many of the world's oceans, from the stormy North Atlantic to the unpredictable Southern Ocean. Some waves have reached heights of nearly 30 meters, towering above ships and platforms, just as sailors had reported for centuries. Each measurement contributes to a growing database that helps scientists understand the conditions under which these waves form. Observations show that rogue waves can appear even in moderate weather, arising from the complex interaction of wind, currents, and multiple wave systems. Their rarity and suddenness make them a formidable hazard for anyone at sea. Despite the sophistication of modern instruments, predicting rogue waves remains a massive challenge. The ocean is a chaotic system, and the precise combination of factors needed to create a rogue wave is difficult to anticipate. Researchers are developing probabilistic models to estimate the likelihood of extreme waves in a given region, but real-time forecasting is still limited. Mariners, engineers, and offshore workers must remain vigilant, aware that even in an era of advanced technology, the sea can produce phenomena that defy expectation. Modern technology has not only confirmed the existence of rogue waves, but has also allowed scientists to study their formation mechanisms more closely. Linear superposition, nonlinear energy focusing, and interactions with strong ocean currents have all been observed, contributing to the sudden appearance of massive waves. With continued monitoring, researchers hope to better understand patterns that could eventually improve early warning systems, enhancing safety for ships, oil platforms, and coastal infrastructure. Yet the ocean retains an element of unpredictability, a reminder that no matter how advanced our tools become, nature can always surprise us. These modern observations show that rogue waves are not isolated anomalies, but a natural part of ocean dynamics. They validate centuries of sailors' reports and underscore the importance of ongoing research to understand, anticipate, and mitigate their impact. Even with today's technology, a rogue wave can rise without warning, proving that the ocean remains one of the most powerful and unpredictable forces on Earth. Science behind the waves. The ocean is like a hidden orchestra with countless waves rising and falling in a rhythm that seems predictable, until one note gets dangerously loud. Rogue waves are the result of this complex symphony of ocean dynamics, where multiple mechanisms combine to create waves far larger than their neighbors. One of the simplest explanations is linear superposition, where several waves traveling in different directions happen to align perfectly. When their crests coincide, they temporarily stack on top of one another, producing a single wave far taller than the average. It's like cars in a traffic jam piling up at just the wrong moment, forming an unexpected obstacle in the middle of a smooth road. But linear superposition is only part of the story. Nonlinear focusing plays a crucial role in amplifying wave heights. In this process, energy from surrounding waves transfers into a single wave, allowing it to grow disproportionately. In the ocean, this energy transfer can turn a relatively normal wave into a rogue wave within seconds, catching anyone at sea completely off guard. Currents and winds add another layer of complexity. Strong ocean currents, such as the Gulf Stream or the turbulent waters of the Southern Ocean, can interact with existing wave patterns to concentrate energy into a single wave. Winds blowing in alignment with currents further amplify this effect, creating conditions where rogue waves are more likely to occur. These interactions are not fully predictable, which is why even modern forecasting struggles to anticipate the sudden rise of a giant wave. Rogue waves can appear in areas that seem completely ordinary. The North Atlantic and Southern Oceans are particularly prone due to their strong currents, frequent storms, and converging wave systems. Researchers have observed situations where waves as tall as 30 meters arise from otherwise moderate seas, validating centuries of sailor reports that had once been dismissed as exaggeration. The convergence of wave energy in these regions creates a perfect storm of physics, producing waves that tower above surrounding swells in an instant. In simple terms, rogue waves are nature's way of concentrating chaos. Multiple smaller waves interact, sometimes constructively and sometimes destructively. When the conditions align perfectly with wave trains crossing, currents strengthening, winds pushing, the result is a sudden, massive peak. Scientists have been able to model these interactions using modern computing, showing how rare yet inevitable such waves are in the chaotic environment of the open ocean. The unpredictability and suddenness make rogue waves particularly dangerous, as even the most prepared ship or offshore platform can be caught off guard. Understanding these mechanisms is not just an academic exercise, it has practical implications for maritime safety. Ships are now designed to withstand extreme wave heights, and offshore platforms are engineered to endure rogue wave impacts. By studying linear superposition, nonlinear focusing, and current interactions, researchers aim to improve prediction models and reduce the risk to human life. Yet, despite advances, the ocean maintains an element of surprise. Even in areas monitored by satellites and buoys, a rogue wave can rise suddenly, reminding us that the sea's hidden orchestra sometimes plays a note so powerful it commands both awe and respect.